Hey, this problem is a classic integration by parts problem. So we're going to start out with assigning a u and then finding du and then v dv. So u we're going to let be natural log of x. So du is going to be 1 over x dx. And then over on the other side we have v, but then we do need to go ahead and assign dv, which dv would have to be x to the 4th dx. And integrating that would give us 1/5 x to the 5th. Now we're ready to plug in our formula. So we have u times v. So we're going to have the natural log of x times 1/5 x to the 5th minus the integral of v, so 1/5 x to the 5th du, which is 1 over x dx. And we definitely need to simplify some of this other. So I'm just going to bring down the natural log of x, 1/5 x to the 5th, minus, and 1 over x is going to cancel here, and we're going to have a 4 left. And then we'll be moving out this 1/5. So we're just integrating x to the 4th dx. And then from that portion, when we integrate there, again, all of this comes down. We have minus 1/5 times, and if we add 1 to 4, we're going to get 1/5 x to the 5th plus c. So putting together the entire answer, you're going to have natural log x times 1/5 x to the 5th minus 1/25 x to the 5th plus c. Okay, our next problem, again, we need to assign a u value. So starting off, we're going to let u equal x. So du is going to be dx. And then we need to assign a dv and v value. dv, I would assign that to be e to the 2x dx. And the reason why is whenever we integrate e to the 2x, remember we get 1/2 e to the 2x. And now we're ready to substitute into our formula. So we have u times v minus the integral of v du. And then this is a lot easier for us to integrate. So here I'm just going to bring down minus, and we'll move out that 1/2. And then integrating e to the 2x, we see that we're going to get 1/2 e to the 2x back. And putting all this together, we have x times 1/2 e to the 2x minus 1/4 e to the 2x, and then plus c. Okay, for this problem, I would assign u again to be x, and so du is going to generate dx, and then we have v, dv, and dv I would assign e to the 3x plus 2 dx, and again, once we do our integration of that, we're going to have 1/3 e to the 3x plus 2. And we're ready to plug into our formula. So we have u times v minus the integral of v du. And again, here we're just bringing down our x and our 1/3 e to the 3x plus 2 minus, and we would move our 1/3 out. And again, if we integrate e to the 3x plus 2, we're going to have 1/3 e to the 3x plus 2. And then we have plus c. All right, this problem starts out very similar to the other problems. U is going to be x, and so du is going to be dx. And then for dv, we're going to assign that to be secant squared x dx. And when we integrate that, that's going to give us tangent x. So now we're ready to do u v minus the integral of v du. Inside this, keep in mind that here we're going to bring down x tangent x minus the integral, and I'm going to change tangent to be sine x over cosine x in order to integrate this. Now there is a formula we can memorize, but sometimes it's a little bit quicker just to go ahead and do the integration part. We have x tangent x minus. Now with this fraction, always check to see if I take the derivative of the bottom, do I get the top? And in this case we do. The derivative of cosine is negative sine x. If the derivative of the bottom is the top, then I know that's going to be natural log. Now the only difference here is a sign, so we can move that out to the front, and that's going to cancel with that sign there. So really this is going to become plus natural log of cosine x, and then plus c. Okay, now this problem, we're going to start off a little different because we don't have just an x here to assign to our u value. So we have to decide, well, what can we let u be? And you can start either place, but I would go ahead and let u be x squared plus 4x, because if I just do the derivative of 2x here, I'm just going to generate a 2x, and that's really not going to get us anywhere. Whereas doing the derivative here, we're going to have 2x plus 4 dx. So that is going to generate a different piece for us. So maybe that'll help. And then that's going to mean that dv is going to have to be e to the 2x dx. And when I integrate that, that's going to give me v, which is going to be 1/2 e to the 2x. Now let's go through and see. We're going to have uv, so I have x squared plus 4x times 1/2 e to the 2x. So uv minus the integral of v, 1/2 e to the 2x, du, which is going to be 2x plus 4 dx. So this is a good indication over here that we're going to have to do this integration by parts again. Now, a few things we can simplify here. This 1/2, we can distribute that through inside the parentheses. So I'm just going to move this integral down, and we're going to have e to the 2x times x plus 2. That's going to be a little bit easier to work with. Always simplify those small values if you can. And so now we're going to go through our process again. So we're going to let u be x plus 2. So that would imply that du is dx. And then dv, we're going to let that be e to the 2x. So then v is going to be 1/2 e to the 2x. And so I do need to bring all of this stuff down. So I have x squared plus 4x. I need to move it down just a little bit more. So we're going to have x squared plus 4x times 1/2 e to the 2x, and then minus, and then we're going to have this whole process again. So uv, so x plus 2 times 1/2 e to the 2x minus the integral of v, 1/2 e to the 2x du, which is going to be dx. All right, so we have one more integration place to go. So I'm going to just keep bringing all this stuff down. So we have x2 or x squared plus 4x is 1/2 e to the 2x. And I'm going to distribute that negative, so it's going to be negative x plus 2 times 1/2 e to the 2x. And then the negative way out here, that's going to make that a positive. And now we're ready to integrate just this portion here. So I would move out that 1/2. And if I integrate e to the 2x, that's going to generate another 1/2 e to the 2x, and then plus c. All right, really strange problem here. We are going to start out not with integration by parts, but we're starting out with u substitution. So we're going to let u equal cosine x. Du would then be negative sine x dx. And solving for dx so that we can do the substitution, du over negative sine x is equal to dx. So when we come back over here and do our substitution, we have sine x times natural log of u, and then dx is going to be du over negative sine x. So notice those sine x's do cancel, and I'm going to move this negative to the outside. So we're going to have negative natural log of u du. Now from there, we're going to have to do integration by parts. So we're going to go over to the side. Now we can't do a U, so we're going to change that, and that's why she used a W. You can use any letter you want. So we would assign W to be natural log of U. So dW equals 1 over U du. And if solving for du, that means we're going to have U times dW equals du. All right, now let's go ahead and let V and dV is going to be du. So if we integrate there, that's just going to give us a u. So now we're ready to do this integration by parts. So we're going to multiply w and v. So I have u times natural log of u minus the integral of u times 1 over u du. Those u's will cancel, so really I'm just integrating 1 du, which is going to give me a u again. Now, we do have plus c, but we have to go all the way back to the beginning and remember that we originally assigned u was cosine x, so we do need to fill that back in. So value of cosine x minus cosine x plus c. Right, another integration by parts problem. To start off with this one, it's so strange because inside here, if I start trying to integrate that, I'm going to have an extra x that I'm not going to have out here. So in that process, we're going to break this apart, and we're going to have x squared times x, and then I'm going to rewrite 9 minus x squared to the 1/2 power dx. And now whenever we do our u substitution, I'm going to let u be equal to x squared. So du is going to be 2x dx. And then over on the other side for dv, I'm going to put all of that portion together. So we're going to have x times 9 minus x squared raised to the 1/2 dx. And so here for v, and this is going to be where we have to do some u substitution as well when we integrate this. Now when we integrate, we know we're adding 1 to the exponent. So I know I'm going to have a 3/2, and then our u would have been 9 minus x squared. And then that's going to be raised up, not 3/2, it's raised to the 3/2. This should be to the 2/3. Let me fix that. So it's going to be 2/3, all of this to the 3/2. But what about this x out here? Well, keep in mind, if we're doing our u substitution, we need to take the derivative of this stuff on the inside. That's going to generate a negative 2x. So I need to multiply by a negative 1/2 to balance out that 2. So when we simplify all of this, that v value is negative 1/3 times 9 minus x squared to the 3/2. So filling in our integration by parts, we have x squared times negative 1/3 times 9 minus x squared to the 3/2 minus the integral of all that mess, 1/3 times 9 minus x squared to the 3 halves. And then du, which is going to be times 2x dx. All right, so now we're ready to go through all of this again. We're going to have to do another u sub over on this second portion here. Now I am going to move this 2 out, and I'm going to move that negative 1/3 out. So I'm going to have positive 2/3 times the integral of x times 9 minus x squared raised to the 3 halves. And again, same process here. We can do a u substitution over to the side, and if we do that, then we know u is going to have to be 9 minus x squared. Du is going to be negative 2x dx. And so again, we're going to have another 1/2 to cancel out this portion here, or if you want to solve for dx, we are dividing by negative 2x over. So if we do that, then we're going to have to move out another 1/3 there. So this integration, we're going to have that 2 that comes out, that negative 1/2. So that's going to flip the sign back to a negative. We're going to have 1/3. And then again, we're going to add 1 to the exponent. So we're going to have 5 halves, so 2/5 on the outside, times 9 minus x squared, raised to the 5 halves, and then plus c. And we can put all that together. Just don't forget this portion here would also come down. So let's go ahead and write in that final answer. Let's put it all back together. So the final answer here, you have x squared times negative 1/3 times 9 minus x squared, all raised to the 3 halves. And then we have minus 2 over 15 times 9 minus x squared to the 5 halves, and then plus c.